Hello everyone, welcome to Chem Study Zone. So, as we are done with identifying plus and minus and groups, now we will learn how to compare the power of plus and groups and simultaneously the minus and groups. You will talk about plus and groups, plus and where the atom has lone pair of electron. Consider it is directly attached to the carbon atom. And if it has lone pair of electron, that means these are plus and groups. Now, how to compare the power of plus and groups? The first will be your power of plus and groups is directly proportional to the extent of overlapping. Now, as you know, extent of overlapping is greater when size difference is less. If size difference so if size difference is less, well, we have to consider minimum size difference. If size difference is less, then extent of overlapping is more. Is more. Then the plus in power is more. अगर आपका साइज डिफरेंस कम होगा, साइज डिफरेंस किन दो एटम्स के बीच में, कार्बन एंड योर प्लस एम एटम, व्हेन यू आर कंपेयरिंग आपके कार्बन एटम और आपके प्लस एम जो आपका एटम शो कर रहा है विच इज लोन पेयर ऑफ इलेक्ट्रॉन, अगर उनके बीच का साइज डिफरेंस कम होगा दैट मींस एक्सटेंट ऑफ ओवरलैपिंग विल बी मोर एंड योर प्लस एम पावर विल बी more. I will show you with some example. It is considered कि ये डायरेक्टली अटैच्ड है कार्बन एटम से. If you compare carbon and NH2, carbon OH, carbon and chlorine, you have to compare the size difference first. If size difference is less, extent of overlapping is more, and your plus and power will be more. As you know, the order of sizes left to right size decreases because the effective increases. So left to right, your size of the atoms decreases. These atoms are from your second period atoms हैं. Second period atoms हैं ये सारे. So size difference साइज डिफरेंस यहाँ पर होगा, उसके बाद यहाँ पर और उसके बाद यहाँ पर. तो आपका एक्सटेंट ऑफ ओवरलैपिंग भी सबसे ज्यादा एक्सटेंट ऑफ ओवरलैपिंग यहाँ पर, फिर यहाँ पर और फिर यहाँ पर. So your plus and power will be in this order. Now second criteria to compare the plus and power is charge. If charge increases, the plus and power increases. That means charge is directly proportional to your plus and power. Our next comparison is if plus m is due to lone pair, then the plus m power will be more. If plus m is due to internal conjugation. Plus m power will be more if plus m is due to lone pair, and plus m power will be less if plus m is due to internal conjugation. For example, both these are your plus m groups. Here plus m is due to lone pair, here plus m is due to internal conjugation. It is involved in conjugation not involved in conjugation. Okay, some more example. Lone pair is involved in conjugation. Sorry, lone pair is not involved in conjugation, but here lone pair आपका conjugation में involved होता है. Here plus m is due to the lone pair, and here plus m power is due to internal conjugation. Comparison of minus m groups on basis of their power. Minus m power. Minus m group are those which have pi bonds. The first atom has pi bond. The first atom have pi bond. Now your minus m power is directly proportional to your electron withdrawing nature of first atom. This is your nitrogen sp2. This is your carbon sp. This is carbon sp2. Carbon sp2. Minus in power is directly proportional to electron withdrawing nature. This is you can compare on the basis of electronegative also. This is more electronegative. This is little less electronegative. This is the order of minus in power. As you can see, your minus in power is directly proportional to electron withdrawing nature. In carbonyl groups, if side atom has more donation power, then your minus in power will decrease. In carbonyl groups, in these cases, it will donate like this. So minus in power will be decreased. Okay, now there are some major points about mesomeric effect, which are there are few important points about mesomeric effect. First one is mesomeric effect. M effect does not operate on meta position. You can understand it by example only, else you can't understand what I'm trying to say. So your plus M group, as you can see, first atom has lone pairs. Will show the movement of electron like this only. Your final structure. As you can see, there is no charge development on your meta position. So mesomeric effect doesn't affect your meta position. So as you can see, there's no charge development on meta position. So meso effect doesn't operate on meta position. This is example of plus M group. Now let's take the next example of minus M groups. Minus M are your electron withdrawing group. If your first atom has pi bonds, then they are called as minus M groups. Okay, so what we will do? We will transfer the charge electron like this. Double bond plus. aromaticity regained. So, since charge is on ortho position, is on para position, but at meta position, there is no charge gradient. So, our next point is to understand which groups are orthoparadirecting and which groups are meta-directing. Consider this is your group. If G is plus M, means the first atom has lone pair, then so it will donate electrons. It donates electron, then here will be a negative charge. Here will be a negative charge. As you know, M effect does not operate on meta position. If electrophile comes, electrophiles are those which has less numbers of electrons or which needs electron. If it needs electron, that it will go where electron density is more. Basically, electrophiles are electron loving group. There is electron density more. Electrophile can come here, here, and here. So if your G group is plus M, so they are orthoparadirecting. Second is your minus M groups. That means first atom has 5 bonds. So the electron withdrawing group electron density will shift towards G group. If electrophile comes, that is electron loving species. Electrophile will attack where electron density is more. So your minus M groups are meta directing groups. I hope you understand which groups are meta directing, which groups are ortho para position directing. Now your second point is hydrogen bonding may increase or decrease the acidic strength. This is a carboxylic acid. This is how it behaves as an acid. Now consider this OH group. Here H bonding is taking place, so it is more stable conjugate base. That means it is more acidic. Now, this is the case of increase of acidity due to H bonding. The second case is of decrease. So it is more acidic, mean it as B and it as A. A is less acidic than B due to hydrogen bonding. Due to hydrogen bond. There are some effects. There is a point acidic strength of also substituted aromatic carboxylic acid increases. Now consider a aromatic carboxylic acid. It is also substituted. Here is group G. This one is always more acidic than A, your or aromatic carboxylic acid. Basically, this is your benzoic acid. The G should be bulky group. This is not applicable if the group is non-bulky. G cannot be chlorine, hydrogen, H2, cyanide, OH. This is also called as ortho effect or SIR effect. Steric inhibition resonance. Now, there are some points. There are applications of an effect as compare basic strength. So your basic strength basicity is directly proportional to the availability of one pair. Availability of one pair. Basically, your basic strength is directly proportional to your plus n power or your minus n power, and inversely proportional to minus n power, or plus I power and plus n power. Sorry. minus n power and minus I power. The atom has localized lone pair. It will be more basic than which one do not have localized lone pair, or which do have delocalized lone pair. Localized lone pair not involved in resonance. You can clearly see this is involved in resonance. For organic nitrogenous base, the order follows this sequence: guanidine, amidine, amines, imines, amides, cyanides. This is the order of basic strength of organic nitrogenous base. Its application is to compare the acidic strength of carboxylic acids. Now, the acidic strength of carboxylic acid is directly proportional to minus n power and directly proportional to your minus a power also, and inversely proportional to plus n power and plus I power.